Hi, and welcome to this AWS for Industrial Web Day session entitled Accelerating Actionable Data to Optimize Production with MachineMetrics on AWS. I'm Joe Rosing, and I lead business development for discrete manufacturing solutions at AWS. Joining me today are Dennis from Morgan Olson and Graham from our partner MachineMetrics. Now, in manufacturing, a key trend is to leverage ever-increasing amounts of data to enable new capabilities. Examples include digitally executed manufacturing, where we're enabling smart factories to automate non-value-add activities and drive increasing amounts of productivity. A second area is products as a service, where we enable new as-a-service business models and revenue streams. A third area is connected products, where we use data to redefine the customer experience and create new forms of differentiation. And finally is sustainability, where we can use data to help reduce energy costs and reduce our impact on the environment. Now, when we talk about digitally executed manufacturing, we find hybrid architectures are driving Industry 4.0 initiatives and solutions. With hybrid architectures, we enable the most efficient and economical way to run workloads and processes on premises and in the cloud in order to improve the ability to experiment and innovate quickly, implement Industry 4.0 use cases such as AI/ML, all at scale, and to drive the outcomes that matter to manufacturers, all at a lower total cost. A primary way that we're helping industrial customers achieve this is through our AWS for Industrial initiative, where we're making it easier to digitize, monitor, and optimize industrial operations. With AWS for Industrial, we're uniting purpose-built industrial services from AWS with our partner solutions, all under a single initiative to accelerate the time to value, regardless if your scope includes a new greenfield manufacturing plant or decades-old equipment. Now, as an example of where we're accelerating value for customers with our partners, today I'm excited to present with our partner MachineMetrics. With AWS and MachineMetrics, customers are able to leverage the unmatched years of expertise, purpose-built services, security, and scale of AWS, while taking advantage of MachineMetrics' easy-to-use platform application, manufacturing subject matter expertise, and simple integration of data-driven insights into common workflows. Together, AWS and MachineMetrics are able to offer customers a faster path to delivering bottom-line results with data and automation all at scale. To learn more about MachineMetrics and introduce our customer speaker today, I'll hand it over to Graham Immerman, VP of Marketing at MachineMetrics.
Thanks for the introduction, Joe, and hello everyone out there. My name is Graham Immerman, and I'm the VP of Marketing at MachineMetrics. Joe is absolutely right. Successful industrial IoT initiatives can be dramatically accelerated through an ecosystem approach of vertical solutions. By selecting the right technologies and properly leveraging the unique technology, IP, and domain expertise of each participant, manufacturers can optimize rapid value attainment and reduce their risk of failure for those initiatives. The simple truth is that manufacturers don't have the time nor the resources to rebuild the wheel from scratch every time, and neither do companies like MachineMetrics. Leveraging powerful AWS services as a foundation for our platform allows us as well to accelerate value attainment for our customers. And by focusing our efforts on development and innovation around our product, we can continue to deliver secure, high-performing, resilient, scalable platform for machine data and applications in the industry, which for our customers is far better use of their time and resources than building a solution themselves. So, for those of you who do not know us, please allow me to reintroduce us. MachineMetrics is an intuitive and flexible machine data platform that easily enables the collection, monitoring, and analysis of data from any piece of manufacturing equipment to deliver powerful, actionable insights and automations for factory workers in a matter of minutes. And doing so, we can drive decisions from anywhere in the world at any time that go right to the bottom line for any factory starting from day one. For most manufacturers, digital transformation should start with capturing insights from the heart of manufacturing operations, which are essentially the machine assets that make these products and people that run those machines. These assets likely represent the largest capital expense for any manufacturing organization and are producing thousands of data points every second. Yet, remarkably, this data is not being captured or analyzed to improve efficiency, which stifles continuous improvement. Factories of today are still consumed by manual processes that lead to massive inefficiencies that can affect every component of the organization. This is evident in the MachineMetrics benchmarking report, which you can see here, that states that the average machine utilization rate is less than 30% across the thousands of machines that we begin monitoring and collecting data from. However, the data and insights driven from this data can provide a foundation for any manufacturer to grow their business and differentiate themselves competitively. In fact, it is highly probable that the inefficiencies that exist at the machine level are the lowest hanging fruit to creating massive business impact, not to mention a catalyst for driving many future automations. Enter Industry 4.0, right? The silver bullet to solve manufacturing problems. Not so much, according to McKinsey. 81% of industrial IoT implementations actually fail. And this is because each implementation often requires very specific domain expertise that is difficult to find. It's expensive and often time consuming. For example, in discrete manufacturing, which is the vertical that we operate in, there are hundreds of different OEM machine builders with no consistent standard of connectivity. Getting data from these diverse assets is challenging, often requiring outside system integrators. The problem then multiplies after getting this data from all these different assets, because once the data needs to be represented without a common data structure, it makes building analytics and out-of-the-box use cases almost impossible. Generic solutions cannot truly solve manufacturing vertically specific problems without custom system integration and application development, which for most manufacturers slows down value acceleration for the factory floor. To address this problem and for the digital factory to reach scale, this needs to be simpler, and MachineMetrics has done exactly that. MachineMetrics was designed to reduce friction for digital factory initiatives so organizations can start using their data from day one and start realizing the benefits of that data immediately and continuously without having to rebuild the wheel from scratch. Today, hundreds of manufacturers have connected thousands of machines to MachineMetrics across global factories, from mom and pop job shops to some of the largest manufacturing organizations in the world. And these companies are leveraging our plug and play machine data collection, monitoring, analytics, and automations to optimize shop floor productivity, increase their manufacturing equipment utilization, and maximize their capacity for production. So how do we do that exactly? Well, the foundation of the MachineMetrics platform is the automated capture and standardization of machine data. Many companies do this manually today, which is time consuming, inaccurate, and the data is oftentimes inactionable. MachineMetrics largely gathers the data directly from the control of the machine, automating that process, which is where most of the critical production data lies. And this bypasses the need for additional sensors and the complications involved with their installation to provide a scalable solution that can be self-installed by our customers. And last year, during COVID times, when many manufacturers were not allowing people within their factories, 90% of our customers were able to install our platform without us ever coming on site, and we doubled in size as an organization. Now, to connect our edge device to a machine or a network of automated machines is simple, and it takes just 20 minutes for automated manufacturing equipment. This capability enables consumable machine data and insights in a matter of minutes. Now, it's not the hardware that's extremely extraordinary. MachineMetrics Edge platform, the software that runs on this in this image that you can see here on the screen box, features dozens of custom software adapters developed to automatically map out CNC machine data on the control system. And to do so, we had to support dozens of different protocols for data, including MT Connect, FANUC Focus, OPC UA, UMATI, Mitsubishi Control, Heidenhain, Citizen, Siemens Numeric, Ethernet IP, Modbus TCP. MachineMetrics Edge platform also supports digital analog I/O for machines without a standard connectivity option to integrate even the most challenging equipment. Now, that edge device, which I said our customers often call the little green box, which you can see here in this image, can be configured remotely, all within a web-based application. It's an easy process, similar to figuring out your at-home IoT devices. And once your edge device is configured, adding machines is very simple. You give it a name, a make, a model, select the edge device you configured, select the connectivity method for the machine or network of machines you're connecting, and you're on your way. Data is then instantly streamed from the edge into MachineMetrics cloud platform, which is designed specifically for manufacturing equipment and the high volume of diagnostic, performance, and sensor data that's associated with these complex manufacturing equipment. The MachineMetrics multi-tenant cloud platform, which is built on AWS, ensures that all that data is gathered and processed in one centralized location so to deliver secure, reliable remote access from anywhere at any time. Our analytics engine then identifies patterns in the machine performance and health, which can generate insights that initiate actions via configurable workflows and automations. This is also where we can push data into a customer's S3 bucket or other AWS services like SiteWise, QuickSight, SageMaker, SAP or Oracle Cloud, or any other ERP or system hosted by AWS or any other internal internet service provider. Lastly, but not least, out of the box applications deliver immediate use cases that can drive instant value on top of your data, including real time dashboards, flexible reporting, rules based workflows, predictive alerts, text email notification systems, all of which deliver optimized processes to factory workers. You can also build your own apps in the cloud or on the edge, or seamlessly integrate MachineMetrics with your current shop floor systems to automate MachineMetrics data across your digital factory. Now, accurate real-time data automatically captured and transformed from machine assets creates a solid base for driving bottom line value across any organization now and continuously. We've found that when combined with visibility and actionability through alerts, analytics, and automation triggered by that data, a 15 to 20% improvement in utilization and machine performance can be realized in a matter of months. And that can be millions of dollars for any company's bottom line. Once this foundational piece is in place, value achievement can then be accelerated in a number of directions by integrating this data into other siloed data residing on enterprise factory or organizational systems, from product design to production to quality to maintenance to logistics. This is a concept that we call harnessing the MachineMetrics digital thread. And in doing so, you can drive endless automations and opportunities for remarkable value faster than ever before. And here's a visualization of what that looks like. We have customers leveraging data from their assets to drive their CMMS systems, instantly transforming their maintenance systems from one based on calendar time or reactive maintenance to one driven by machine alarms and conditions. All you have to do is integrate through an API or through one of our webhooks. And just like that, your maintenance platform is now being driven by actual data from your factory floor. The same thing can be said about ERP systems. We have customers that are integrating data from operators into their HR software and now automating performance reviews across dozens of factories. And in doing so, MachineMetrics becomes the operating system of an autonomous factory, an engine that can empower factory automation with machine data. And we're still just in the early stages here of showing what's possible. But I urge you not just to take my word for all of this. We're excited to have one of our customers here today who has achieved remarkable and rapid success with our platform across their organization. I will now turn it over to Dennis, who can share their story himself.
Thanks, Graham. My name is Dennis. I'm the Continuous Improvement Manager at Morgan Olson in Sturgis, Michigan. We manufacture trucks for the last mile delivery, and we did a project with MachineMetrics, supervisory control and data acquisition. So basically, what we did in our process was we used the DMAIC process: define, measure, analyze, improve, and control. This is mainly a data-driven exercise in terms of in the continuous improvement exercise. The Kaizen team included our fabrication supervisor, Brian Reed, myself, Dennis, our maintenance manager, Keith Langer, and Mark Hamlin, who is our maintenance tech. We had support from IT, and MachineMetrics sent us a technician. His name was Chris Schaefer to support our integration project. Um, in defining the problem, we had a big issue where we had lack of data driven machine supervision and live machine monitoring. So we were running our fabrication process in the blind. We had difficulty in justifying machine capacity requirements because of lack of annualized data. Unavailable quick prompting, just in case a machine went down. or an operator was not at the machine. Um, Automated downtime categorization. We had paper-based categorization of downtime. And one thing that we did, we tried to step on the scale and see how much our utilization was. And we were shocked to see that it was at 29%. You don't know what you don't know. So we did a 60-day trial, a COVID trial for 60 days, just to validate that the project will be sustainable. We had to get approval, and MachineMetrics partnered with Morgan Olson to get a 60-day trial before we could purchase the full-blown implementation across all three facilities. The machines that we chose for the trial were in Virginia and Michigan. So we had two machines in Michigan and two machines in Virginia. That was for the trial phase, which was done in the year 2020. During the trial phase, you can see on June 15th, we started with a utilization of 29%. By August 10th, we had moved it up to 69% by using MachineMetrics, visibility and accountability across the shop floor. Another machine category, we looked at in cycle. Was the machine running or no? On June 15th, we were at 41%. By August 10th, we were at 67%. The data was obvious after the trial phase that we need to do something about how we run the fabrication process. So you can see there by day, we started at 29%. By the time we were done over the 3 month period, we had reached a high of 72% in terms of machine utilization. This trial phase was mainly done in Michigan in collaboration with MachineMetrics. We tried it also in Ringgold, Virginia. We had two machines in Ringgold, which we used for in the implementation. And you can see we moved from 20 to 31% and 29 to 49%. At this time, we were starting a new facility, so the data was not very clean. This was not a stable plant, but Michigan had been running for close to 30 years, so the data was very valid at one location. Um, Data analysis. In the analysis stage, we started getting downtime by machine, and it could give us a downtime Pareto. So Pareto basically tells us we have limited time, limited resources. Where do we focus on? Initially, we used to have paper-based downtime categorization. They scan it and keep it in a system where no one ever goes back to look at that data. For this, for the capability that MachineMetrics gives us is anyone, anytime can go back and see what machine was performing well and what were the downtime reasons and act on the main reasons for downtime. So this is a dashboard of machine implementation. So we implemented 25 machines in Sturgis, Michigan, and this was in the trial phase. We wanted a proof of concept in the Michigan location before we moved it to Virginia and also the state of Tennessee. It was a quick ROI. We are fully confident that we've been able to recover the costs that we used in the purchase of the MachineMetrics hardware and software. Another key thing was if I'm a supervisor and I come in on first shift at 6 o'clock, I could go back in time and see what was third shift doing. So that's an example of a brake press 182B. I can see on an hour by hour basis how did third shift perform. Again, I could look at a punch machine. I want to see utilization for the punch machine. So I could go hour by hour for the punch machine. How did third shift perform? I was not there, but MachineMetrics gives you the capability to go back in time and see what the performance was. After full implementation, we put a TV in the fab shop office, a TV in the maintenance office, and another TV on the shop floor. It gives you visibility and enhances a sense of accountability for everyone in the production process. Anyone with a username and a password can go into MachineMetrics, look at what the performance was, and basically make assessments on how to move production towards one facility or the other based on performance. At the shop floor level, we have team members who have a tablet. Basically, it's showing you if you're winning or losing. No one has to come and supervise you. You're your own supervisor at this point. And the operators seem to like it because no one's coming to their area to tell them what to do. The tablet at the station, it gives you a gauge on how well you're doing throughout the day. So, screenshot in Michigan, we had True Punch 1 and True Punch 2. That's a snapshot of time on 6/19/2020. And then on August 6th, you can see the drastic change on a typical day. We moved from 41% to 83% and 37% to 72%. Your typical view in June was very different from the typical view in the month of August. This was for Virginia. As I had mentioned, at this time, we were still starting up this facility. So the data may not have been very clean, but for Punch Genius number one, you can see the change over the 2 month or 3 month period from 18 to 77%. Um, on the left, this is how we used to track our downtime. It's a piece of paper. You could lose it any time of the day. And on the right, you can see how much improvements we have made by digitizing it and keeping that historical data to make future decisions. The manual tracking on the left, it's very unreliable, and you cannot easily get data driven decision making with that information. Um, on the shop floor at the machine, the most important person there is your team member. The key role of the tablet, you enter your downtime reasons, which is summed up as the day goes. You get a visual indicator of how, if I'm winning or losing, if I'm the team member there. It communicates with maintenance and fabrication management in case of downtimes. You get a visual management at the cell level. So if I'm a supervisor, I just need to walk around the plant and I can easily know what machine needs help and what machine doesn't need help. And also, MachineMetrics customizes the tablets based on the needs of the business. So, an hour by hour indication of if I'm in the red, I need some help. If I'm in the orange, I'm getting close to the green. If I'm in the green, I'm hitting my standard for the day. So another inaccurate entries of downtime was another reason we had. On the left, you can see we used a piece of paper and relied on team members to write down what they were, what downtime reasons they had. On the right, you can see it's a drop down menu, give me the reason, and MachineMetrics captures that data automatically. And what was typical on the left, you would see increments of 5, 10, 15, 20. On the left, you see 19 minutes, 50 seconds, very precise to the second of what the machine was doing or not doing in case of downtime. So before, after, and impact to operations, a summary, high level summary of what was done. Our baseline utilization was 29%. Our utilization improved to 73% over the implementation phase. This was close to $500,000 in savings if you just gained 10% as an assumption. No visibility before. Now we have visibility for maintenance, fabrication, and operation managers. And also the shop floor team member has the ability to know if they're winning or losing as the day goes. And the impact to operations is that transparency across the fabrication is enhanced. Lack of machine utilization data, number three. Capacity requirements based on annualized data is now easy, and it's readily available to know, do I need more machines or do I need to reduce my production rate based on the data we get from MachineMetrics. Number four is manual entry of downtime. We have automated entries of downtime tracking now. It's very accurate, and it doesn't rely on somebody to write it down and waste paper and waste time to do it. Manual notification in case of downtime. We get texts to the supervisors and group leads in case a machine is down. So the response time has been cut down significantly. We don't have to chase somebody down basically saying, my machine is down, please come help me. You get a text message with escalation systems. It moves from 10, 15, 20. By the time it gets to 30 minutes, it's on the fabrication supervisor's desk. The sixth one was lack of data to decide between different brands of machines. Today, we can easily tell what machines performs better than the other based on data from MachineMetrics. This helps you in making purchasing and capital decisions. Thank you, everybody, for watching. Have a great session.